So we have Michael Duke, Victoria University, Luke,
Stay on here
and
because we are recording.
Jordan.
So the camera.
you can start.
Okay.
So
Don't trip.
we'll start with Michael Duke.
Yeah.
We'll be talking about integrated water treatment process for valuable nutrient recovery and purification from industrial waste streams.
All right, thanks, Stefano. It's a great pleasure to be here, and with my presentation, I'll just give a very high-level update on what we've been up to on our project. As Stefano mentioned, is titled "An Integrated Water Treatment Process for Valuable Nutrient Recovery and Purification from Industrial Waste Streams." So we've seen this just in sort of identifying where the focus area of this, and actually other projects that we're involved in, being that we're very much an industry-focused research group at Victoria University. We can take this well-known sort of flow chart. This one's from the Stockholm Environment Institute, which talks about circular economy, sort of, and identifying where's your wastes. Let me get there we go. There's your wastes, and they come from a range of sources. Obviously, where this hub, we have big focus on human excreta, so urine, big focus, and also synthetic shit is. I feel sort of funny to say in front of everybody, but it's okay in this crowd. But also too, we focus on many sources of waste, and essentially what we sort of look at is it's really sort of driven by the industry that we're working with, but yeah, to basically take a waste and repurpose it. And within that, you have not only just the nutrients and organic matter, and obviously the water and other things like certain minerals, but there's also an energy component. And for many years, actually, we worked at Victoria University on membrane distillation, and that was able to take the thermal energy and also process the stream. But anyway, so we're up to this point here where we've got the valuable resources, and the reuse is on the side of the market. So, the customers who take that. So you've got an industry, a utility, for example, who has a waste, and then you've got supply chains which are already active in producing plant fertilizers, soil conditioner, and other things. So, so really what we want to do is take this diagram and sort of break it up to say, okay, well, if I'm a process and environmental engineer, how can you realize this? And there's a big challenge, and I've been working in this for a very long time, to work out where you can get not only the push from us researchers, but the pull from the industry to pick up what is utilities who are really driven to treat to a certain environmental and health related targets, to industries which are very much business driven, and they have very different priorities. So we look at break it up. So you've got we capture so the process, in terms of the process engineering here, you capture the products in the waste. We've seen some wonderful talks on this, and this is what we're trying to do in this hub, is sort of to work across these 3 points, and essentially we've got the selection and concentration of identified resources. So these are now getting into, so you've got your collections, then you've got your treatment processes, to then move it to the next step, which is then to move, and this is a big focus of what we do, to move from those captured products and isolated products to make them meet the specifications of these applications or these industries. So what we've done working with Parkway Process Solutions, who's our partner on this hub, in prior work, we have developed this process called AMES, or AIMS. And the whole idea is it takes a mixed, in this case, the focus was inorganic solutions, so salty wastes, and look at, that's very mixed, and there's many things in salty wastes, and look at how we can undertake a series of separation processes and reactions to take it from this mixed waste all the way to commercial products. And along the way, everything has to be considered. So in working in these projects, very much focused on, on commercial outcomes. Not only are we targeting one thing, and I'll show in the next slide what that component is, but I'm just sort of talking in a more general sense, and pulls out, reagents and fresh water. But you also have to find ways in which you deal with the byproducts as well. And if you bring in any third-party chemicals, where do they come from and what's their fate? And this all has to have an answer in order for it to go anywhere. So this work it's already online through Parkway's website. It looks at a feasibility on potassium sulfate for making potash in a way that takes a mixed waste and is more sustainable than other processes that can do something similar. So we focus in this case this is mineral extraction. We have a big focus around mineral. So mineral fertilizers, for example, would be the case relevant in this hub. So and we focus on optimizing that and make it energy and water efficient, and also ticks the box also too in terms of it has a business case, and it also helps the environment. And we took this mixed salt, this case is just some salt lake salt, and use it to basically produce these ice, through a series of separations that we developed to produce high purity sodium chloride, potassium chloride, leonite, which is a potassium magnesium sulfate, and ultimately potassium sulfate. And we sort of worked on this at laboratory scale and then moved into pilot scale. And so Stefano, you talked about the process of getting approval for your pilot plant. We had not sort of a different experience where we had to get a building approval for our container, a pilot container, so in order to use it safely. So before we were able to commence operation or move into the container, we had to get the council to basically approve it, and that included all the sewer connections and everything, and the waste management and other things like energy efficiency of the shipping container, which was an interesting experience. But you can sort of see here we go from bench scale, where we'll demonstrate some new idea for separation and produce a high purity product potentially. I go from the sort of beaker scale. There's the analytical work, and we really focus on the chemistry, going back to the chemistry fundamentals. And this is an example pilot facility that we built. And there's so many questions you have to answer in that. It's the materials of construction. You've also got, batch to continuous type theory that you have to get on top of, and sort of really move it to a point where you can produce these products that you can demonstrate with purity analyses that allow you to demonstrate the real potential. So with the hub we've been working on is fits on the theme fertilizer optimization, and introduce our team. So Noel Dow and Christian E. So Christian, as Sean mentioned in his overview, has just joined us earlier this year, and he has a background from analytical chemistry. So we're really great to have him on board. And yeah, so and the focus here is to sort of build on the process to really coming more from that sort of market sort of end to building the process and having a system that can take mixed waste. So it's quite adaptable to whatever industry waste we're going to work with. So just in terms of just some high level, so there's no results slides here, but just some where we're up to and some of the motivation. So it's about developing this flow sheet with a series of processes, and taking a range of mixed industrial wastes, and basically we now working in organic contaminants as well as mineral contaminants, and convert them to valuable products, and also think of not just the product that's being produced, but the cleanliness and the way in which we can deal with waste byproducts as well. So we've got to remove contaminants. This is a big focus in a lot of our work, and we produce fertilizers among many other things. So it's not only fertilizers, we produce other products that are both mineral and organic based. And as I mentioned before, it's the same sort of process. We look at demonstrating at lab scale, and then use that to then there's so many things that must be measured at the bench scale in order to consider what design features are necessary to make it in pilot and continuous, which we end up going ahead and doing. So where we are now, we've developed flow sheet for a range of industrial wastewaters. We've conducted bench scales, complete involving separation, concentration, and converting, purifying all the major and minor components for market value. And ongoing tests to further separate impurities from waste streams and isolate and concentrate products, and then demonstrate from the bench scale, and use that to build a pilot plant, pilot equipment. So that's all I have to update for this particular meeting on this topic. But hey, I thank our team, and particularly Bahe Elskokmak, who's the CEO and Group Managing Director of Parkway Process Solution, and his engineering team, and our research team, and We had Peter Sanchiello before, but he's finished up now, and now we have Noel Down Christian. So thank you very much.
Thank you, Michael. And we will come back with questions at the end of the session. Next, we have someone online. Where is it? Zoom.
Hi, Stefano. Can you hear
Oh,
me?
hello. Yes, we will soon be able to see you too. Can you hear me?
Yes, I can hear you.
Brilliant. So we have Liu Ye from the University of Queensland, and she's giving us some updates on her project on greenhouse gas emissions, I believe. Sustainable literature management and its effect on carbon footprint. So another way of saying greenhouse gas emission.
Yeah. Can you see my share screen?
Yes, we can see the presentation.
Okay.
So we are going to, but we don't see you though. More.
Okay.
Just remove pin from. Yeah, we can put it on speaker or. Okay, so you're good to go, Leo. The room is listening.
Okay. Hello, everyone. I'm not sure if you can see me. Sorry, I couldn't join in person this time. I was there on Monday morning, but I have to come back to UQ for teaching obligations. So I have to deliver this presentation online this time. And I'll talk about my project involved in the hub. So it's really about sustainable nitrogen management on related carbon footprint. How do we manage the wastewater treatment better in terms of remove and recycle nitrogen? Okay, so my industry collaborator is Melbourne Water and Icon Water. So this presentation is prepared by me and Dr. Zhiyao Wang. So Zhiyao is recently joined the group working part-time on this project. And she's a research fellow and have a lot of experience on nitrogen cycle related. So the research progress, so we started the full-scale monitoring on 2 treatment plants operated by Melbourne Water and Icon Water. We have quantified some full-scale nitrogen emissions. I will introduce some of the results later. And also in the meantime, we are looking particular 2 aspects. One is on a biological urine stabilization system, how we incorporate N2O emission on the urine conversion. In the meantime, we have started to look at another aspect, which is through a novel acidified microorganism to support the urine conversion to overcome the current inhibition proceed to the NOB culture. So for the full-scale side, one treatment plant we quantified is operated by Melbourne Water in the Western treatment plant. So this plant particularly tried to recover biogas in the end to remove the nitrogen. So we have used the floating hoods, and so these little dots here are the floating hoods we put and try to capture the flux. So we are quantifying both the methane come out as collected as the energy source, and also the later on dissolved methane emitted through the hood together with generated nitrous oxide. So from the results on the nitrous oxide, we have carried out monitoring, and we have found that a lot of spatial variations in different locations. Especially we found the later pass that has much more emissions than the previous pass. And then for methane emissions, again, very dynamic along with the year as well. And also majority of the methane is more stripped out because of the dissolved methane. So most of the methane is coming from the front, and N2O is coming from the later pass. So when we look at the average emissions, you can see that long-term emissions did show very different emission flux on different time. So overall, this N2O contribute to majority of the carbon footprint. And also we found that because of the previous COD used as energy support, so which result some insufficient carbon that used for denitrification and result to the later higher emissions of N2O. The other plant we studied is operated by Icon Water, which is located in Canberra. So we look at both the biological reactors through the similar flux sort of method. Also, this is the furnace which they used for incineration. For Icon Water particularly, that they try to recover phosphorus as the through the chemical precipitation at the beginning, and then through the incineration, that the ash of this of the solids actually contains a lot of phosphorus, and later on can be used as fertilizer. So yeah, so this is the results. We can see that the overall again from this total quantification, that this purple one is coming from the nitrous oxide from the biological part. And then the next part is actually nitrous oxide from furnace. So this is through the thermal conversions that the nitrogen is also converted as nitrous oxide in the furnace of gas. Overall, the captured methane through this flux only contribute to a minor part. So through this, we also found later on the higher emissions of the N2O is also may partially contributed of the chemical dosing for precipitation, so that a lot of solids or soluble COD is also removed in the primary settler, which resulted incomplete carbon supply to the denitrification. Okay, so overall for the full-scale study still ongoing, we have more sort of work to be done to further explain how we can better optimize the process to achieve more carbon neutral or reduced emissions. Next is about N2 emissions from the biological urine stabilization. So this is when we talk to Sean that when they try to convert ammonia, high ammonium into ammonium nitrate. So a lot of this conversion currently is end up with nitrite accumulation, and also it's quite difficult to achieve ammonium nitrate. So one thing is ignored is about the N2O emissions from this conversion process. So a laboratory study is try to set up, understand how the N2 emissions is associated with this urine stabilization process. So we currently developed with two laboratory systems. One is on the using a biofilm based on the membrane aerated bioreactor. The other one is through suspended sludge. So we try to compare the nitrification performance N2 emissions as well as how stable that we can achieve this urine conversions under different designed stage. And then, as mentioned, it's very difficult to achieve ammonium nitrate because of the inhibition of NOB. Because NOB is very sensitive to pH and also with free ammonia and free nitrous acid inhibition. So currently research mainly focus how we can avoid NOB inhibition. So we try to promote actually a new or a novel acid tolerant NOB culture. With this NOB culture is very tolerant with low pH and also very tolerant with FNA conversions. So when the ammonia was converted under the low alkalinity, when pH drops, that this type of NOB will not be inhibited. So, so this is the currently we have already enriched this acid tolerant NOB culture in the lab on this carrier, the chip-based system, and then we have tested that this under pH 4.5 to 5.8, this co-enriched nitrifier culture has very high activities that can convert ammonia, also nitrite, to a relatively high rate. And then the next stage is we're going to conduct more systematic design and demonstrate using the synthetic urine to see the nitrification rate by different cultures and also characterize the kinetic response in these studies. Also, we have recruit a student who will be focused on specifically on the laboratory part, including these N2 emissions and also the novel NOB cultures. Yeah, so thanks to all my collaborators, especially Peter, James, and from Melbourne Water, Claire, and also Ben from Icon Water, and also the team from UQ. That's all. Thank you.
Thank you, Leo. Are you gonna stay online until the discussion?
When will be the discussion? Because
In 10 minutes.
in 10 minutes.
Yeah.
Yep. Okay, I will stay because I have a meeting. I have to leave at 2:50 for the 3 o'clock meeting.
Okay, so we'll have time to ask you questions then. So thanks. So last talk of this session, Jordan Roots from UTS, and he will cover governance models. Which governance model should we adopt for a thriving circular economy of nutrients?
Hi, everyone. So I'm based at the Institute for Sustainable Futures at UTS. And what we do there is we like to take an inter and transdisciplinary approach to sustainability issues. My background is law and social sciences, so I guess I'm wearing more of a social science cap today compared to some of the engineers and natural scientists in the room. But I think it's really important that we meet in these rooms, like we saw in the Olsen case, where they have lots of collaborations between different disciplines to ultimately get to the final objective that we're striving for. So let's step back and figure out where a circular nutrient economy sits within the larger circular economy umbrella. So the circular economy can be thought of as an umbrella concept grounded in well-established environmental disciplines like industrial ecology, the waste hierarchy, and ecological economics, and premised on key principles such as eliminating waste and pollution from the economy, circulating products and materials for as long as possible at their highest value, and regenerating natural ecosystems. Under this conceptual umbrella, other circular economies are nested, which apply to specific sectors, such as the circular economy in the food and agriculture sectors, and the circular nutrient economy of organic byproducts, which sits within it. It goes without saying, sorry about that. It goes without saying that the success of achieving a circular nutrient economy will greatly depend on the kinds of scientific and research innovations that we're working on here in the NiCE Hub. However, what is now becoming clearer to circular economy experts in different fields around the world is that the success of achieving a circular economy in any sector, whether it be industry, manufacturing, the built environment, it's largely determined by how the system is governed. But what does this elusive term governance really even mean? An important distinction must be made between the terms governance and government, which are not the same despite them often being used interchangeably. Government refers to the formal institutions and people responsible for running a country, state, and city, such as the federal, state, and local governments in Australia and the ministerial representatives that serve within those jurisdictions. It's the official system that makes the decisions for a society, like making laws, collecting taxes, and managing public resources. Governance, on the other hand, and what my research focuses on, it's a broader concept. It's the formal and informal processes and practices that different actors, like governments, businesses, not-profit organizations, universities, and individuals, apply in different social contexts to steer collective behavior towards a particular objective, like a captain steering at the helm of a ship. For example, an educational campaign coordinated by NiCE Hub to communicate the benefits of urine-derived fertilizers at a festival with its NiCE Loo, or the Liquid Gold podcast that Kerry and I are working on, that would be an example of governance, the practice being the educational campaigns, and the objective being to better inform the local community about a circular nutrient economy, who can then share their knowledge with others and drive wider systemic changes within the food system. Essentially, governance is the formal and informal rules that we make to live, work, and play together at every scale of human activity, which are ultimately informed by our underlying cultural value and belief systems or paradigms, as demonstrated here in this iceberg analogy. The meaning of governance will vary depending on the context in which it is used, such as a corporate context and the governance of supply chains, compared with governing natural resources in the environment. However, while it is now widely accepted that governance is an essential factor in achieving a circular economy, there is not yet a coherent understanding of what exactly governance means in the circular economy literature. Recognizing this, in the first year of my PhD, I've been conducting a scoping review of the peer-reviewed literature by applying the PRISMA SCR methodology, which I hope to publish next year. I won't bore you with the methodology, but essentially I've identified 1,796 articles and book chapters across various databases, wherein the terms circular economy and governance are contained in the abstract title or keywords sections. After applying various screening criteria, I got this down to about 118 articles and have now extracted data from these to better understand what the association is between the terms circular economy and governance, which includes innovative examples of governance models from around the world, which we can hopefully learn from and apply in the Australian context. I divided the review process into two parts. The first part focuses on the facilitators and hindrances of circular economy governance, and the second part focused on the different governance theories that are being discussed in the literature. So, as I mentioned, the central focus of the literature review was to determine what the key governance facilitators and hindrances are to understand how stakeholders across the agri-food value chain can better integrate into nutrient circular economies at appropriate scales. As you can see, governance facilitators include the enablers and drivers to a system, while hindrances include the challenges and barriers. I further categorize these using a framework for governance instruments, which includes but is not limited to instruments like laws, market mechanisms, policies, education and training, and institutional changes. From my research, I discovered that some of the key enablers and drivers of effective circular economy governance included changing policies at different jurisdictional levels so that there is a clearer vision of what the circular economy looks like for different stakeholders along the value chains. Amending statute laws so that they're more uniform across different jurisdictions and providing a clearer regulatory framework for industry actors to follow. And introducing market mechanisms such as providing government subsidies and tax rebates for small and medium-sized enterprises to implement circular business models. On the other hand, some of the key challenges and barriers to circular economy governance included siloed and linear government institutional structures that do not collaborate effectively. Competition and consumer laws prohibiting the sharing of data between companies, and also a general lack of trust in consultation with the local community, which can block development plans, such as being the case for several anaerobic digester projects around the world. System thinkers would refer to these governance facilitators and hindrances as leverage points in a system. A leverage point is basically an intervention point in a system, in a complex system, whether that is within a corporation, national economy, a living body, city, or natural ecosystem, where a small shift in one thing can produce big changes in everything. Here is a framework that explains the most influential places to intervene in a system to achieve systemic change arranged in an increasing order of effectiveness. What you can see is that the governance facilitators and hindrances that are currently being talked about in the circular economy literature from my scoping review sit more at the top of Meadows' framework, such as making changes to taxes, standards and subsidies, the structure of information flows between actors, and changes to the rules of the system, such as laws, punishments, and constraints to actors along the value chain. Don't get me wrong, while these governance instruments are all important in their own right, they do not necessarily address the deeper paradigm shift of the broader system, such as the culture, value, and belief systems from the iceberg analogy earlier, which has been identified by system scholars as the most influential leverage points to intervene in a system. Considering how important paradigms are for leveraging a system, the second component of my scoping review was based on understanding more deeply the governance theories that are being discussed in the circular economy governance literature, as well as what the focus of governance is according to these theories. I believe this can provide an indication of where the key priorities of circular economy governance are to date, whether that relate to the design, recirculation of materials, or regeneration of nature principles. My scoping review revealed that these are the most referenced governance theories in the circular economy literature, ranging from articles published from 2004 to 2024. Environmental, collaborative, network, circular economy, and multi-level governance are the top 5 most referenced theories in the literature, followed by top-down and bottom-up, transitions management, local, public, and institutional governance. What you can see on this governance matrix is that there's a general skew in the focus of governance in terms of systems that are governed to the benefit of humans when it is applied to areas and sectors of the circular economy, such as waste management, plastics, and the built environment. You may be wondering why environmental governance is not positioned further to the left of the matrix. Surely the central focus of governance is on the environment itself, according to this theory. However, if you look at the history of environmental governance, it is predominantly focused on the conservation of natural resources for the benefit of humans, whether that be for economic purposes, like the management of trees in the forestry industry, or to protect national parks and lakes for tourist purposes. Meanwhile, theories like network and collaborative governance focus on how independent networks of actors across government, industry, academia, and civil society can coordinate their decision-making to have mutually beneficial outcomes for each of their interest areas. To date, the emerging theory of circular economy governance, which is based on some of these other theories of governance, tends to focus on a mixture of traditional top-down public governance, where decisions are made by central authorities, such as governments, and bottom-up governance, where decision-making starts at the local or grassroots level. While there may well indeed be beneficial outcomes for the environment that arise through these different approaches to governance, I would contend that wherever the focus of governance is driven by a value system that positions human needs over the needs of the environment, the system will generally prioritize human development and growth at the expense of nature, which will ultimately lead to the further degradation of Earth systems. If we think back to the umbrella diagram from the beginning of the presentation, these approaches to governance paradoxically undermine the third principle of the circular economy, which is to achieve a circular economy that regenerates the natural environment. Over the coming years, I'm interested in what this means for the future of the circular economy. Amending plumbing regulations and toilet standards across different jurisdictions so that they're more uniform, and improving collaboration between government departments and businesses along the nutrient value chain will all be important for achieving a circular nutrient economy in Australia. However, I believe it's at the paradigm level that the biggest leverage points to changing a system can be achieved. What we need to decide as NiCE Hub researchers is what are the kinds of cultural value and belief systems we want to drive the governance of the circular nutrient economy now and into the future. So before I finish, I'd like to pose a question to you. What are the underlying cultural belief and value systems or paradigms that are underlying your individual research? Looking forward to the future, how do you think that these paradigms will impact the governance of the circular nutrient economy as it develops in Australia? Thank you.
Okay, so the discussion shall start. So we got the 2 local speakers that should line up on the slope there. And please, if you could prioritize questions to Liu so that we can send her off.
Stefano.
All right, so Liu, you don't see anyone, but everyone sees you. So,
Okay.
okay, who would like to ask a question? If you don't have one for Liu, that's fine. I will ask. Yeah, Gary?
Well, yeah, question.
You posed the question, I guess, was it related to how we link the human centric kind of approach versus the impact on the environment. I guess from your research, what's back to you, what's your answer? Like, I guess it's sort of trying to create that link that environment is, we know that environment is intrinsic to the survival of humans, but they don't think about it very often. So
Yeah.
link that to the circular economy, I guess.
Yeah, so one, I guess, governance approach and theory that I didn't mention up there, but what I'm really interested in exploring in the coming years is this idea of earth-centered approaches to governance. And there's different practices that center around this, and how that can be brought into the circular economy context and start shifting some of those paradigms. An example of that could be, and you see some of these cases around the world, legal personhood approaches where you give rights to natural ecosystems like lakes, rivers, standing within the court, so that you know, the idea that you would dump effluents into it and pollute it to the point that there's eutrophication, that would that would be illegal in a sense. You have, you know, nutrient trading schemes around the world. I'm not an expert on those, similar to carbon credit schemes, where you can have, like, that's a market mechanism that you can introduce. But yeah, starting to think about, you know, how we give a voice to the environment. But not only that, like, if we do give a voice to the environment, are we really going to listen? So that's where I think the paradigms, the belief systems are really important to address as upstream solutions, rather than these more downstream solutions like amending laws, you know, tax subsidies, all important, but yeah, I think it's at the bottom of the iceberg that, you know, make a really big impact.
I got a sort of follow on just a question for you, actually. Just in relation to your study, in the water sector, there's a big now push towards cultural values and First Nations, you know, values in water management, which has actually led to some interesting. There's some paper published recently about how you know, First Nations approach to water management, or just their approach to the environment, is that people are a part of the environment, and they have to work in harmony. So I just wonder if you've sort of looked at that, because in the water sector, with the new strategies being put out, at least in Victoria, that I'm aware of, there's a big push towards First Nations, you know, self-determination and cultural values and cultural flows, such as, you know, going into decision making.
Yeah, I've heard about that in the water sector as well. It's like one of the kind of circular economies where you can have water flows. But those First Nations cultural values and knowledge systems are a big part of those earth-centered approaches and rights of nature approaches to governance, like in the academic world. It's also kind of an umbrella concept, this idea of rights of nature and earth-centered approaches. But First Nations and Indigenous knowledge systems are like a really big, important component of those disciplines, and I'm really interested in also bringing that into my research, so that we don't have such a Eurocentric and Western approach to the circular economy, which is a current trend in circular economy research.
Is that for Liu? So just hold on for a second. I'll ask one to Liu, because otherwise she's gone and then I miss the chance. And then we'll come back to this flow. So Liu, I just have a question for you. I'm wondering, do you expect to see higher N2O emission factors from the nitrification process in urine compared to what happens in conventional wastewater, and why?
Okay, if you just using biological nitrification to convert urine, answer is yes, because it has been proved that higher ammonium loading is certainly a promoting factor. And also for urine itself, it is low with carbon and also low in alkalinity. So those factors will also easily generate nitrite, high nitrite accumulation during the conversion. So that means that if NOB cannot convert the nitrite into nitrate, this will also propose even inhibitory effect on the AOBs. So not just the high ammonium loading, but also the initial high free ammonium and later on high free nitrous acid. This will all be inhibitory effect. So common nitrification process with ozone conversion, the answer is yes, we will see higher compared with the emission factor point of view.
So it is interesting because you missed my talk this morning, but I showed the results of N2O emissions of synthetic wastewater at different levels of urine diversion that we created in the lab. And interestingly, the higher the percent of urine diversion, the higher the emission factor, despite the nitrogen loadings were lower. So we went 1 to 7% at 75% urine diversion. So we got the highest emission factor, and there was nitrite accumulating and struggling to come down. So one that could have to do with COD to nitrogen ratio, because loadings cannot explain it.
So it's because there are multiple pathways. We have to see in the system which pathway is promoted, which pathway is more sort of reduced. So I haven't seen your results, but we'll be keen to see if you can. Yeah, we can discuss further.
Take this offline and try to work.
Thanks. Thanks, Stefano.
Okay. Any more questions for Liu? Okay, then we can say goodbye to Liu because she's going to go to another meeting. Thanks for making time to join us.
Yeah, everyone enjoy the rest of the discussion. Bye.
Bye. And so now back to Anne.
Thanks. It was a really good summary. The article, you were really looking at circular economy and those paradigms. I think there's a lot of discussion about planetary health, ecosystem health, One Health paradigms, which really are ecocentric and holistic. And I think the dialogue changes when you get into the practical elements. It's the who's talking and who's having the conversation. When it gets into the engineering types of articles, you don't mention the word paradigms. You're talking about technical processes and systems and chemicals, and I think it drops off. So there is a lot of dialogue about that, and the circular economy sits in the middle, because you do get talk of paradigms, and the circular economy is consistent with the SDGs and what it means, non-human life. But when it gets into the more techie types of journals, that discourse disappears.
Yeah.
And I think that's important. Maybe that needs a bit of needs some of you people working in that industrial engineering space to start inserting it back in.
Yeah, I think that speaks to your point you made earlier about the kinds of journals we're looking to publish in as a NiCE hub. Yeah, exactly. And getting together and collaborating, because yeah, the kind of stories you tell about the circular economy. Exactly, yeah. You'd be surprised, like, some people don't really care about this stuff, unfortunately. So yeah, how we translate and educate people is super important, and how we engage with different academics working within the larger circular economy in different sectors is super important.
Okay.
Question for Michael about your team's process. It looks like it's a great process to recover valuable minerals from concentrated solutions. Does it work for brine as well?
Yes. Yeah. So the feedstock is was salts, mixed salts, and we trialed it on salt lake salts, but principally they're all similar compounds and components. So yeah, that's the logic.
So how does AIMS compare with processes like Solvay or Salt Rock in terms of their technical knowledge?
Okay. The economics, as I mentioned, that's the thing, that there has to be kind of a case for it to work, and a case that was of particular interest for that study that was for this was potash. So really looking at different alternatives to provide potash. When it comes to brines and other processes out there, sort of just generally, you know, processes that will concentrate them, so like reverse osmosis, as electrochemical processes as well. And they all have their issues as around the contaminants and dealing with those, and membrane fouling, just something we do a lot of in our group. So not to can't give you a specific answer, because it probably does depend on the context of what's being pulled out and of the brine sort of value, and what waste has to go out and what contaminants in there as well. But yeah, I guess that's you know, what we're sort of really looking toward is how can we utilize these processes. And there's actually some interesting technologies coming out that can do some very interesting separations that are not really widely studied, but they're out there, particularly from some commercial suppliers that sort of really you know, quite excited to work into to learn more about, because it's moving quite a bit in the separation space for how you can get pure products from mixed brine, or mixed, in this case, brine solutions. But yeah, I can't specifically answer your particular one, but we can chat separately, and then, you know, we can go into some technical detail about the processes you're looking at.
So is NiCE your proprietary?
Oh, that's, yeah, Parkway. So we work with the sort of enhancing it, but no, it's like if you look at the Parkway website, you'll see that information is it's their process, yeah.
Certainly have time to keep it going, but we can also think smartly.
Yeah.
And in consideration of the fact that Joanna has to leave early, we could start early on the workshop, which then would allow us to take a break and get some tea during the workshop, and make sure that we get it done properly. So if it's no more questions, however, if there is one, we'll take it. All right, so join me in thanking these two wonderful speakers. And so we're going to veer off schedule. So we're going to allow Joanna and Anne to kind of explain what is going to happen. This is optional, so like every project that requires ethics approval, there's always a sentence that says participation is voluntary, which means that you will not be stigmatized if you decide to take a break and just go for a walk instead. But if you participate, you need to sign a consent form, and the consent forms are on all the tables.
No, I have
So
to
if
log
you have
in
not
online.
done that, but you think you can participate, please do so. And when morning, if the afternoon tea comes, you're all welcome to stand up and refill again if you still have any space.
So while you're finding the forms and everything, I might just take a chance to introduce this part of the project. The NiCE project is involved in the safety assessment. And those of you who heard Yvonne's talk at the conference, we talked about the NiCE technology, this urine diversion technology, to really take off. It needs to have some certain prerequisites. It's got to be technically feasible, so the engineers have to be able to design something that works. It's got to be economically viable, which is what Sayed is modelling. It's got to be socially acceptable, which we haven't really cleared. We haven't got someone working actively as well on that. But it's also got to be safe. So we could get through all the other, tick off all the other boxes, but if it's deemed not to be safe, then the health regulators will come and they'll just stop it from being implemented. So we're not, unlike, sometimes people think of us looking for health risks. We're not trying to find things wrong with it.
Oh, thanks.
We're trying to identify
That's,
potential health risks that
presenting
are
now?
associated with the production and use of this urine-derived fertilizer to be ahead of the game. we don't want the risks to emerge. There's nothing worse than the risks making the press and blowing up afterwards to say, you've released this thing on the market and it's going to spread the next pandemic of virus. And so they're the unintended consequences. So a lot of this, because we can't, it's very hard to detect microbial pathogens in any product. You know, it's expensive. One test can cost you $1,000 and you only find what you go looking for. So which of the hundreds of pathogens you go looking for, right? So in microbial health risks, we tend to use modeling approaches. We know very well what's in sewage. There's, you know, for decades, we've been modeling and managing microbial hazards and viruses and pathogens in sewage. We don't know how well characterized pathogens are in urine. There's far fewer papers. But I naively used to think, you know, many years ago that urine was sterile, right? You know, but it's not. I was sitting next to a virologist who said, let me tell you stories about urine. And you can see there are ways in which pathogens can get into urine, but how well do those pathogens survive the treatment process? And then the sneaky one coming up the side is antimicrobial resistance, right? We've got a CRC in Australia called SAFE. It's got 10 years to investigate the global problem of antimicrobial resistance. And we certainly don't want to produce a circular economy solution whilst propagating antimicrobial resistance. So, and that's a little bit trickier to model because we don't have dose response relationships to model for antimicrobially resistant bacteria, let alone viruses and fungi and AMR genes and the horizontal transfer of AMR genes. So it's a bit of a black hole, but they're on our horizon. You know, we're going to be considering them and there's a lot of unknowns. But Johanna's got a PhD to do is to start and finish within 3 years because she's determined to finish on time. And we're coming into it, you know, it's already the second year, but we have to have some boundaries about what we model. And there's things that are a lot possibly in there, likely to be in there, but then there's also those hazards that people perceive to be in there. And with the modeling approach, we can actually model perceived risks as well as the ones that are likely to be in there. So what we want to use today is draw some scope around it because we have, it's not infinite. We don't want to waste time. We don't want to model stuff that's trivial. And we also want to use this sort of project to give a reality check. You know, people use toilets every day. They come into urine contact with urine every day. So if we can explicate, you know, these are very familiar hazards. Don't be scared of them. They're no worse than what you would be using a toilet. So we can demonstrate that. But then, so today is very much, I'll hand over to Johanna, who will take you through about what we want to gather the information on. Their opinions, we're not testing your knowledge, it's just perceptions and views. And it won't be the last time we talk to you about it because if she's at the beginning of this sort of modelling, we'll have a chance, you know, next year to check and we'll give you an update of where we're up to. But hand over to Johanna.
Yeah, thanks, Erin, for this great introduction. Don't think there's that much more to add. As for the workshop, it should take about 50 minutes. We have some questions and some reserved questions, which would be great to answer as well. I hope if you have all signed the form and could hand them on this table then later on before leaving, that would be great. I just give you a quick background, 5 minutes, that hopefully will help you a little bit for the questions. So as Amy was explaining, we are doing risk modeling and we are using the quantitative microbial risk framework. It's widely applied for recreational water body or for risks to model risk in recreational water bodies, surface water, drinking water, and so on. And at the moment, I'm still in the beginning of my project. So we are at part 1 of 4, which is the problem formulation, or it's used to design risk scenarios, so to trace the risks from the source to the exposure. So we are looking at the potential microbial hazards, so whatever the different hazardous factors are, as well as the how likely they are, how probable they are, maybe how unlikely they are. and how they combine with the exposure, and how do they form the risk in the end. And I found this just coming here 5 months ago, being very afraid of sharks in Australia. I found this nice graph you get a little bit of an understanding to differentiate between risk, hazard, and exposure. So these are the 3 elemental things for risk modeling. So I thought this was quite handy because, yeah, sharks are apparently like all over the coast, as far as I understand, but they aren't always there. So I guess when you go in the morning, there's a higher chance versus in the afternoon. So that's a bit about the hazard is there, but when and how probable is that? And that's the same with the exposure. I mean, the sharks can be there, but if you don't go swimming, you will never be exposed. So then you need both of these to actually have a risk. So I hope that helps a little bit with the analogy. So to not, the instructions. So we have, 6 questions, some in reserve. The questionnaire is entirely anonymous, but if you like, you are welcome to exchange on your table with your table neighbors on the questions. That's always nice. So if you're sitting alone, feel free to group up with some people, get a bit cozy. So yeah, you can discuss the questions. To help us, you could join using that code on menti.com on the Mentimeter. This is great for us because I don't have to write down the results and I have them immediately. If you do not want to answer or you don't know, then I think in some cases there's a don't know option or just do not answer. That's fine. And as far as I know, after each question, we can see the aggregated results. So we don't see who said which answer, but to just see the average, because we're all in science, we love statistics. So that's always great to see some immediate results. If you could give me a thumbs up that you have all been able to join the Menti, that would be great. So someone still missing? See a couple of people. And questionnaire. Oh, that's a bit and just to make sure, are you able to read all of these answers on your phone? Okay, that's good. So the first question is, are the identification of the end users? So with end users, if we use the what would we want the fertilizer product to be used and marketed for? That's the first question. And I believe you can use as many answers as you like. If it takes some time, don't rush into an answer.
That's really important for us as to what final end users you would like or anticipate to think for, because we can make it as safe as possible and not as fit for purpose. Right?
Do you mean within the NiCE project, which end users do we think are most important, or in the world, or ideally, you know?
Ideally, yeah.
Like, how safe do we want to make this product?
Yeah.
Yeah, gardening is quite popular.
And with all of the 6 questions, you can choose as many as you want.
Yeah, so these are not necessarily mutually exclusive responses. So it's what Aim was saying. This is really related to, or gives us an idea how safe the product should be. If it's used for gardening, then it's less like safety is a little bit less relevant compared to food crops if you eat them. So that's a bit.
But for all of the 6 questions?
No, there's different. There's different. Yeah.
Oh, yes.
Yeah.
Says it right.
Yeah.
We're gonna have a discussion about each one as we go, or just
Yeah, why not? Actually, that's a good idea.
capture some, if we're recording this, so we can capture it. But if anyone has any thoughts on this, you know, like we voted, but you can see everyone seems to be sort of happy to have it on ornamentals. And the least, you know, food crops that require processing or food has no cooking. It's interesting that those are equal. Because cooking is a kill step, right? If you cook it, you're going to kill off, unless they're toxin producing bacteria. Cooking doesn't stop that. But it's interesting that they're equal. Does anyone want to comment? So ideally, if we want to be able to use this fertilizer on berries and eat them straight away without cooking, it's got to be pretty safe.
Yeah, maybe a broader question about the question. You know, like when we're talking about reuse of wastewater, you know, or any water, we talk about like a log removal, a cascade of, you know, uses or fit for purpose.
Yeah.
Is it too complicated to think about that with urine as well, that some urine fractions might be treated so that you can use them for, you know, for food crops that don't require cooking, whereas other, you know, urine processes will be good for those other ones, so that it is fit for purpose, and we don't need to, you know, go to town with our treatment processes for all, you know, urine. But
So we have
consider that.
ranges of products.
Yeah.
So from this project, do we want to produce a range of qualities, or do we want the NiCE from you, Val, and you, Gold? I guess this is particularly for these two systems. How safe do we want it?
I just think follow on from that, I mean, like, you know, the class A treated water, so
Yeah.
that's reused on
That's right.
food crops.
Fit for purpose.
Yeah.
And I understand that's all just about pathogens. I think nutrients can be in there anywhere, as long as the pathogens are not there.
Yeah, I know.
Then,
That's just it. You have, we can't test for pathogens, so it's got to be based on this log reductions.
yeah, but for instance, class A water is a thing. So,
Yeah, there's a lot of debate around that though, whether we should, because if we only test for a coli, it's not really.
but, you know, if it's treated to class A, then it can be used on.
Without cooking,
Yeah.
not without a lot of complaint though from health people.
So this is meant for Val and you, Gold?
Yep.
Or also urine untreated? Because
No, this is meant for, we're modeling these two systems, not all urine systems.
You've got to be careful on the definition of garden use, because, you know, there's a lot of people that produce food at home, that's specific garden. So,
Right.
you know, there's a risk profile
Right.
associated with putting on
Yeah,
food crops in gardens, so you want to split that out.
we
Home
had
garden,
about,
food,
about
food
10
production.
different categories, and we thought it was too big
Yeah.
to need it. But
Yeah.
You could
So it's
take that,
ornamental.
just have it ornamental,
Ornamental.
Yeah.
and you've got food crops as a separate one.
yeah, it is meant to be just ornamental, that one, so it's not for eating.
Yeah.
Those gardens, you know, it's fertilized, but
Yeah, we originally had like 12 answers, but
Yeah.
it gets difficult to read, and we differentiate between public and private and all this stuff. But yeah, I mean, this is also quite gives us quite a good idea if you have like guidelines on this later on, like how you classify certain things. If you look at the wastewater reuse guidelines, there is different uses have different standards. They're more stringent, less stringent. So this
That's
definitely.
wastewater. We should have
It's
those
yeah,
guidelines
exactly.
for
That's
urine.
true. Yeah.
Something else, your comment reminds me of a conversation we had a year or so ago, which was both a philosophical and pragmatic discussion around, do we start as an entry point with ornamental, you know, gardening stuff to get buy-in, to get people to trust that this works,
And then
you
spread it
can
out.
get scale up,
Yeah.
or, you know,
Would we go to the,
we are in a crisis at the moment. We cannot afford to wait. We have to, like, you know, go hard from a philosophical perspective because the world is crumbling around us. And so we can't really afford to sort of take, you know, incremental tinkering steps. We need to be transformational. So these are big questions I think we need to think about and answer, and there's trade-offs.
and there's trade-offs, and that's why it's important that we're doing the economics. So say it's a co-supervisor with, because we want to, you can make any water clean, you can put it through enough dollars, right? So every time you add a treatment step, it's going to be more expensive. So how precise do you want to be? And there's processing steps, then there's on-site management, like you can have subsurface irrigation, you can have hydroponics, other ways of preventing the water coming into contact with the edible bit. But it's just that how many scenarios, so we haven't got a real winner there.
Well, lawns is not included their turf, but that's a big potential use.
It is, yeah.
Fertilizing golf courses and lawns is huge, like in Yates, you know, it's a big growth area for us, it's lawn fertilizers and anything to do with lawns, so that's a really significant entry point.
Has
You know, for urban
anyone,
use.
has anyone done sort of a pie chart of all the potential uses? If we can get 90% of the anticipated uses with minimal human exposure, if we get 90% benefits without modern costs,
You need the cost.
Did you share it?
thoughts? We don't have to decide now, but and we can model.
Yeah,
we
it's
can model some
from NiCE, it's
different
not on the PowerPoint.
Yes.
I'm not sure if that makes a difference.
So,
You can share the screen, isn't it?
and then it's consumption.
That's
So
right.
that's what happens if I actually consume something, you know, it's being sprayed with this versus just using it.
Yeah.
So the risk profile is going to be around use.
Different end uses.
Oh, we
That's
can see
right.
it now.
Okay.
So
No, no,
how much do you have to remove to achieve that?
So you still wanna see it, isn't it?
It's fine if I don't like it there. It's like,
And dust suppression or cleaning up, yeah.
I was in there, she said we have to meet, but it's fine.
Yeah, like, they've already found, you know, around plus C, and that's, you know, maybe the nutrients slipped on that, but just.
Yeah. Okay, next one.
Another model.
Oh,
So, like
Oh,
you said,
yeah.
there's no risk without exposure. So in that process, and this is where we rely on the engineers, what are the potential where accidents can happen? So there's the planned procedure, but we also have to factor in potential accidents, you know, where the people collecting and processing the urine can suddenly get a bit splash of it on themselves, or when you're emptying the containers, washing the containers. We'd like to hear from you about what are the most likely routes of exposure. What have we got? Breakage of the urine storage tank.
collection,
Yeah.
handling of stored and processed urine, aerosol dispersion that's really related to spray irrigation, irrigation, spray fertilization, consumption of crops, contamination of recreational water bodies. So that's if, let's say, there's runoff and runoff it's containing the fertilizer and it infiltrates into groundwater or surface water, and the same for recreational water.
What are your thoughts as to why you voted in that way? Like, when you're thinking of contaminating water bodies, what microbial hazards are you concerned about leaching from the fertilized areas into the water bodies? What do you think is moving? The bacteria, the viruses, any microbial genes? What are you worried about?
Nutrients themselves, like.
But we don't care about nutrients. This is only microbial hazards.
Right.
Yeah,
I think there is still bacteria.
bacteria.
Yeah.
Well, you know, in many countries in Europe, when they use composting and stuff, there's a certain riparian zone that you can't apply these biosolids within 25 meters of the river. You know, there are other controls you can have so that you don't spray the fertilizer straight into the water.
So my thoughts on that, I was thinking risk assessments we do for our projects, and there's two, you know, there's the people who have to maintain and operate the equipment, and then of course there's everyone else. And so as when I was looking at this, I was thinking, okay, yeah, the storage tank and the handling of the process urine, that would be the start.
PPE and training.
That's right, yeah, and training versus you got the general public as well. So
Yeah.
is there a distinction between the two, or should you know? Because let's say like
I think
Stefan's
it's
running
a
his
public
pilot
risk.
plant.
The
If the
public
system
health-
breaks down,
Yeah.
it's going to be all full of urine. Someone's got to there and open up the pipes and.
Yeah, I mean, plumbers have to do that already.
I think the difference is also,
Different.
if you look at the collection and handling, that's also where the urine hasn't been hydrolyzed or treated yet, or likely, or there is a
Raw
chance.
urine.
It's so raw urine, opposed to when you apply it to as it's already bottled as a product, then it has already undergone pathogen inactivation.
Yeah.
So that's a bit also the two thoughts
So something
in
like
terms
a
of
hazard-
exposure groups. Yeah.
like a hazard, you know, before you
Yeah.
commission any equipment, you've got to go through all the scenarios, like, and it would be whether it's hydrolyzed or not. You kind of probably have to case worst case situation, worst case scenario.
Yeah.
And sort of avoiding the processes in place to protect people and whatever, that's on the operations side.
To other hazardous compounds, this isn't very hazardous. No,
No.
so, and I think public health regulators are more concerned with public risks and people who are unaware. But I was thinking of your two products. You've got a spray bottle with the ready to use Yovel, then you've got the concentrated one. One has got the potential for aerosolized, and the other one is you're going to spill it over yourself when you're diluting it.
Well,
You know, so
you mentioned that the regulators are concerned about public health, and Work Cover's very, very worried about what we do.
Okay.
Work Cover, yeah, so.
with this one,
So is it the product or the equipment?
both,
Yeah, so I think from the equipment, the operator's point of view, there's a workplace accident, that's big news.
yeah. We don't want that. We don't want the bad press.
Yeah, depends on the risk, so this might be low risk.
So at the moment, we're not getting any blanks. We're not getting any of these categories that no one's concerned about. So you've got a lot of work to do.
But this doesn't capture how much
Well, hopefully
we are
sort of-
concerned.
Sorry?
This doesn't capture the level of concern.
No,
So
no. Oh, well, the priority, I guess.
It's gonna be one of the other questions. Is there anyone who hasn't responded yet, or still wants to respond? We're good? Great.
Right?
Oh yeah. So there's a little bit of background. So normally in health risk modeling, we would consider like 4 points of contact, and that's the left one is some dermal contact that you would get exposure through that. The next one is hand to mouth. That you, I don't know, you grab something, you touch the urine, you eat something, you didn't wash your hands. The third one is inhalation. So pathogens that are volatilized, so they're in the air, so you inhale it. Quite common. COVID, I think, probably was one of the good examples of that. And then the last one is just ingestion. It could be like the bacteria or viruses or what it is on the product you're eating or drinking.
Or
Yeah.
what does it ever accumulate in the?
So that's the 4, let's say, key exposure or points of contacts. Yeah, and I think for this one you can only select one. So
What is the most likely point?
Do you need the soil as another one?
the soil would technically be also
Hand to
accident,
mouth.
yeah, hand to mouth, accidental ingestion. Yeah.
Yeah, we should put urine or contaminated, not contaminated soil, but
or fertilizer or.
the fertilizer itself.
Could be hand to mouth. It could be
I did
hand to-
dilute the concentrated one at home and I put it into a powdered bottle and my son nearly drank it. No, I did put a label on it, but it wasn't big enough.
It's very good. I'm thinking about the label could probably need like translation on it. It doesn't have
Maybe.
English, right?
I was thinking when Ibrahim sent me a sample of it for testing, and it, on the mail order, it said it was hazardous and it was, you had to tick off that it was basically a hazardous waste to send it to me, wasn't it?
Yeah.
Because it's fertilizer. Interesting. So inhalation of bioaerosols not considered by. Okay, so contact with the skin seems to be the most. Skin's actually pretty good at keeping stuff out. It's interesting.
But the question is,
That's
what's the
point
most
of
likely
contact.
point of contact?
Point of contact, right, sorry, yep, good.
It's interesting, on the back of step, how we define urine versus fertilizer.
Yes, when is it raw, when is it stop
Yeah.
being urine?
Versus urine, when it's fertilizer, if we're putting it through this process, are we converting urine to a fertilizer? And then
Yes.
a
At
lot
what
of these
point?
issues go away
Yeah,
when it's called fertilizer versus,
well,
Waste or
Yeah.
waste or.
yeah.
waste or resource, but that's the name changes. But we're still very uncertain about what happens to the actual pathogens in it, at what point do they disappear and which ones disappear to what extent, what log removals do we get through the process? It hasn't been done yet. Stefano's done some, you went looking for some pathogens to win. And you didn't find many.
We just look for bacteria.
Yeah.
We
Exactly, and viruses are the things that, we know that viruses are much more likely to cause outbreaks than bacteria. But then bacteria are more likely to pick up AMR genes and then share them with good bacteria in the soil, so that's bit trickier to model. But
Oh, but happy we have a little bit more defined outcome. Next one. Yeah, that's the one with the fertilizer.
Oh,
So it's a
yes,
similar
so this is your
question.
question. When we actually come, how do we
There's
play
one,
with the fertilizer?
Question was duplicated, so I skipped to the next one, sorry.
No,
I'm not reading the fine print.
So what goes down the toilet is the urine, and what comes out the other end of the processing is the fertilizer. There's nothing in between. There's no real big points of contact in between, is there?
ideally.
It's pretty much closed systems. Yeah.
But if you are talking with somebody from outside Australia, I think even fresh urine is considered as a fertilizer.
Exactly.
And
Yeah.
because there's a lot of people just, if you ask this one probably in underdeveloped countries, I think they
Yeah,
don't
we're
care.
not.
I mean, they just, it's an everyday thing for them.
But it's not just underdeveloped countries. When I was in Sweden, that what urine reuse was
Oh,
direct for urine reuse.
Yeah.
So fresh urine is considered a fertilizer as well. Same with manure, so.
Well, we have a question that's a little bit related to this, but we are coming to that.
Yeah.
Yeah.
Well, I think we can move on.
Oh, yeah. So the next question is about the actual hazards. So the type of pathogens or other microbial hazards. What you think you would be most concerned about. So what is a bit good to know in for the background is there is pathogens that have a higher infectivity and others have a lower, and some are more abundant while others are less. So that's a bit the generally when you talk about a hazard, when we talk about is it a higher or lower hazard, but it's again a bit about how you perceive these different pathogens in terms of your risk. Oh yeah, you already some of the answers. Yeah.
Right, so bacteria equal, oh, okay. People are, is it because bacteria are more familiar to you than viruses? Yeah.
When I'm reading through this, actually, I'm not sure what some of this stuff is.
Yeah,
Yeah.
we thought that, yeah.
Parasites,
Yeah.
I understand, but what's the other thing next to parasites? Doesn't mean.
Oh, the antimicrobial.
Two of the blood pathogens I picked bacteria virus to cover that as well.
That's right, so 3 that overlaps with 1 and 2 categories, like bloodborne pathogens.
Yeah, I thought to put that, no, they're a little bit, but I put that a bit like separate.
Some there put simply to pick up on any associated with menstrual blood,
Yeah,
you know, so are we concerned about that?
but not to sound not concerned with it. The first 2 bacteria viruses is being intended to cover that.
Yeah. I mean, oocysts and they're protozoans, right?
Yeah.
They're quite large, and the membranes, and I think the technology is more likely to remove those simply from size exclusion. Yeah.
All bacteria viruses are like, but they're membranes.
Depends on the viruses. Some are really, really small.
Yeah, viruses are the tricky one, but
Yeah.
you can get at least 4 log reduction in the US, maybe more.
Depending on, but that's only monitored based on the reference pathogen of the adenovirus.
MS2, for example.
Viruses.
But as a means to checking. But
Yeah.
I think they can get more. There's all sorts of like 0.01 microns.
Yeah, no, when you look at the range of sizes of viruses, they're really,
Yeah.
I think that's-
Viruses are a tricky one. but
viruses are
definitely
the tricky.
bacteria,
and that's what I find with the health regulators, their viruses are the biggest unknown, because you only go finding what you go looking for, and there's too many to go looking for. Parasitic worms, did you want to talk to that?
Yeah, I'm just curious if there's anyone who would like to share what specific worms you're thinking about or concerned about. Is this more you were thinking about this in Australia or more as from traveling? Anyone having
There are
thoughts?
papers with parasitic worms turning up in Europe, but not in Australia. But are we concerned about visitors to Australia bringing those in, coming into our systems if they're in public places?
So how they end up in urine? Cross contamination or?
They would be excreted through a urine.
They actually get into the urine.
Because there is
The kidneys don't filter them out.
there is infections that are in the uterus or kidney or in the bladder. So through that, they would basically, what you say, bypass that. So they would never have to be, they will never come through that filter. Yeah.
Antimicrobial resistance, it's interesting. So the awareness of that is rising. And it's the antimicrobial resistant bacteria. But then there's also the antimicrobial resistant genes. And I've just come back from overseas where we spent 3 days brainstorming over a 3-year project about the horizontal transfer of AMR genes through waterways and through wastewater treatments and stuff. And they're very promiscuous, these microbes. They like to share things. And even environmental bacteria and phages are picking up antimicrobial resistant gene sequences. So it is something that's going to be the radar, but there's we will factor it in, but to what extent we can model it accurately because there's no good dose response models out there yet. But it's interesting that it's on your radar too.
Anyone?
May have biased us with your introduction.
For now,
Yeah, yeah, I was just about to say that.
That definitely
Yeah.
made me out of one of my top 3, speaking to you.
Well, yeah. So, but the CRC has raised a lot of awareness about that in Australia. Maybe I biased you, so maybe, yeah, don't worry, your views aren't going to direct the whole research, we were going to stick it in there anyway.
Antimicrobial resistance. I've heard talks from saying water and EPA.
Yeah. And the other thing that's confounds that is microplastics. These genes hitchhike on microplastics to travel through the environment. The whole microplastic debate is confounded with AMR.
Just curious, is there anyone else who would like to share their, I mean, you don't have to, I said in the beginning of, but if you would like to make a remark about your choice, and
yeah,
definitely curious. Not gonna quote anyone, obviously, in the written.
I did my master degree in Israel regarding this microbial movement in the weather zone. So in Israel, they collect the sewage water and wastewater in the basin and they penetrate it till liquefier. And we were just hypothesized that there will be when they pumped the water again to send it to agriculture. And I have found really good result, good for me, but not happy result. But yeah, antibiotic resistant genes and bacteria till 50 meters of 50 meter weather zone, and until the groundwater we pumped it. So there is always antibiotic resistance.
Yeah, it's not surprising. That's where our antibiotics came from,
Yeah.
the environment. You know, we shouldn't be surprised if we find the genes in the environment.
Yeah, that's
The real concern, this is just feedback, is that we don't want to confer resistance to our last line antibiotics. They're the ones, so there's a set of antimicrobial resistance genes that the health departments are very nervous about. Specific ones, anyway. UNSW is a partner in the SAFE CRC. So I was hoping we could get a pilot project up through SAFE, funded by SAFE, that can analyze the final products for the presence of AMR gene sequences through metagenomics. Remember that conversation, John? Yep. We'll follow that up.
Thank you.
Oh yeah, that's that was great. Yeah, that's a bit of background for us. I don't think we have to analyze or talk about that so much.
We can use our spare questions.
Yeah, I happily would love to use my spare questions. Just 3 more. I think it's 3 more. So I hope you're still in the mood. Yeah, reverse question. Yes. So needing some background on this, because we were just quickly touched on that already.
It's not in 2032 Olympics coming to Brisbane, and with our pilot plant being set up in hopefully Victoria Park, there is going to be more and more a flux of tourists and visitors. And to what extent, if we were just doing this project for Australia, we would look at diseases that are endemic to Australia and the risk of those. To what extent should we be considering non-endemic pathogens? Things that aren't very common in Australia, or is that stretching the boundary too much?
I said no, because I think that the biggest exposure will be in the toilet itself, not through the
System.
So
So I think that there is an order of magnitude.
So they're gonna be scared, or if they're gonna be worried about these, they should be worried about them in any toilet, not the urine diverting toilets, is that right?
Yeah, any public toilet.
Any public toilet. So good sanitation practices.
Check the WHO guidelines.
Yes.
Urine.
Yeah.
You see that most of the pathogenic bacteria and viruses do not survive the environment.
For how long?
But I think more than 99% from their report, they never had an outbreak of human disease caused by urine used on plants, except one case, hepatitis B, I think, which is one individual. But I think it's
Yeah, it's that cliche, a lack of evidence is not negative evidence. It's very, very hard epidemiologically to attribute cause to specific microbial pathogens. It doesn't mean that there hasn't been a burden of disease associated with it, it just hasn't been an outbreak necessarily.
I think what now is being discussed is there's any genes in urine that could transmit any antibiotic resistance, like you said, to normal bacteria in the soil, then change that bacteria into something really different. And I think there's a lot of study that was done by the University of Michigan about those.
They're the people we're working with on this, and there's lots of unknowns.
Yeah, they didn't find that those genes end up in those bacteria.
They're still identifying the genes, Abraham, there's still a lot of uncertainty, but they are on the advisory group. Jade from Michigan is on Johanna's advisory team. She works under Joan Rose, so yeah, we've got.
I mean, from my point of view, if there is no outbreak caused by urine, just imagining that it will happen one day might, give you some.
That's not how health regulators think.
Yeah, it's just like,
Yeah.
prevention better than cure.
Yeah.
Yeah, maybe a bit of maybe quick background, a little bit what we've been doing apart from going through the literature is because we're also in touch with Queensland Health. And one thing I've been doing, I've been going through the whole list of notifiable diseases in Australia and looking which one could have the slight tiny risk of causing an outbreak. So I know what you mean. You go through the list and probably 99% says, no, there's no relevance.
Because they don't survive. If you have direct contact with urine, you might get by bacteria or a virus or something. But after 24 hours or 48 hours, most of these things, they won't survive the urine system. Because you get hydrolysis, you get expiration.
That's also something we have been looking into, these parameters, how the hydrolysis inactivates these and how like pH, concentration and temperature.
And storage.
Yeah, so because if you have a regular wastewater treatment plant, we have very set parameters we have pretty set about this treatment unit needs this and this control parameters and it yields this log reduction. So log reduction equals pathogen removal. But for hydrolysis, we don't have that. The membrane is a different thing. The membrane has a bit more, you can say it has this pore size, it's a bit more
verifiable.
Yeah, but for the hydrolysis itself, there's a few papers and all of them use a little bit different set of parameters. And based on that, they have a different inactivation curve. So it's hard to say, which set of parameters you use. And then again, bacteria and viruses have a different inactivation curve. And as a remark to the WHO guidelines, I think they also recommend a 6-month storage time and not a 2-day. Because
and these systems are also not batch produced, they're continuous feed. So you'll have fresh urine coming in all the time. So you don't have a set storage time for a batch. That would have been a critical control point, but we don't have it unless we're on. It really relies on that continuous flow, doesn't it?
Yeah, you can segregate one tank after it's full.
Yeah. Okay.
Batches.
So there's a potential to put in a critical control point if we need to. Next one.
Great.
The elephant in the room. We know that feces contain much more pathogen load than urine, But, cross-contamination, we have urinals have got far less. You're not really going to poop into a urinal. But the cross-contamination in those urine diverting toilets, literally to model it, Johanna has to work out how many grams of feces does the average person likely to cross-contaminate with each event.
Can you imagine my dinner times?
Yes,
That's something we potentially could do with Victoria Park.
measure it.
Yeah, I'm sure that there's a marker of,
There is, yeah.
yeah, feces and we can look for that. And,
Okay.
Surely that's already been done. The Swedes would have done.
Yeah,
that
there is
years ago.
there is
There's
the
not very much.
there is a couple of studies and they come back to the same eco-village where they had these diversion systems. However, these studies are 20 years old and we have to assume that the toilet separation system might have improved by now, but that's
Without
yeah.
empirical measurements, health people are QMRA is horribly conservative. Every step is conservative. You will take the worst case scenario.
Yeah.
So Professor Nick Ashbock did some studies and he's got some rates of transfer, but it'd be nice to have some better data.
Has, like you're in touch with Bjorn Veneros' team at SLU in Uppsala, like they're a huge hub of all this stuff, and Paul Johnson, who's probably retired now, but they would have done all this kind of stuff.
Yeah, that's where the
over
studies
years
come
and
from, yeah.
have updated studies lists.
Yeah, there's only updated studies now. If they did a lot, they don't publish it at this scale. And QMRA has only been mainstream in the last 5 to 10 years in a big way. The modelling. They probably did it before that QMRA was around. Right. So do we have, what have we got, 4.4?
Or
4.4?
it's pretty high.
Yeah.
I think we are getting to the last question. I think. Oh yeah, great.
So this is a free field where you can enter diarrhea sickness.
What's B?
Do you think people are going to vomit in these toilets?
Yes.
Is it a festival?
well,
Yes,
so
they-
at Victoria Park, the guys at City Park Land, so when you come at night, there's a very interesting crowd.
Yes.
So I'm sure that, I mean, they might not bother going into the toilet, but it's typical, but
Yeah, it's the few who spoil it, like, I was doing QMRAs where we're using A-class water modelling, and we said, oh, nighttime irrigation, will only irrigate at nighttime, I said, but all the drunks coming back from the nightclubs are gonna wander through that. I said, okay, we're not gonna irrigate on Friday and Saturday night. It's- Yeah, I don't know how you avoid that, it's. And vandalism are likely to people going to see the urine diverting toilet and deliberately try and poop in it. You know, I don't know. We can't model everything,
I'm sure that would be a
lower risk, yeah.
But yeah, I mean, it will happen. There will be cross contamination from multiple points, and especially when, they haven't been used a lot. So
That's
you just
right.
have to account with that.
And even cleaning, if
Yeah.
improper cleaning could push some feces into that
Yeah.
collection receptacle, but I guess if we do have those critical control points, we can say whatever gets in, we're going
But
to.
also working closely with cleaners is absolutely essential.
Yeah,
And
there was,
ongoing maintenance where you have cleaner casual turnover.
Yeah,
so
that's
training cleaners would be.
that's something that there was a study done by the German GIZ, the Government for International Development, and they had a urine diversion system quite similar to UDT employed in their headquarters in Bonn. And what they found is that one of the highest contributor to cross-contamination was actually improper cleaning, because cleaning staff didn't know, and that's what you're saying, cleaning staff, their turnover is quite high. So I think it was like 30–40% of cross-contamination was attributed to improper cleaning. Yeah, it's actually a simple thing, but yeah, how do you implement it and keep it going? Yeah. Probably by cleaning toilet, I'm not going to think about how to clean it that much. So
I wonder if the waterless, there's one system we've got is waterless, the other one uses a little bit of water, which one is more likely to cross-contaminate?
They're quite different designs,
Yeah.
like the water, I mean, correct me if I'm wrong, the plumbed ones that have a much smaller dam, whereas the dry composting ones have like a much higher thing to the ones that I've seen and used with people think. So I don't know if that changes it.
The waterless one, is it a vacuum?
Look like just the baby.
Oh, you mean where you don't mean a fully dry toilet, you mean it's waterless for the urine and it's still plumbed, flushed at the back.
Oh, is it? I don't know.
So there's lots of different types.
Yeah, definitely what the rest toilet to gravity and that you have a more, you know, that after you
Feces
grow
fine,
the
yeah,
surface,
yeah.
or you have a water and mostly it's water is the chlorinated water.
Yes.
Have water, so it's like disinfection in your like happening when you have a water flushing, even a small amount of water. So I think that
A little bit of water is better.
Water is it is already chlorinated, but they are keep.
Yeah, the chlorine dose isn't meant to kill fecal pathogens.
They also, it works well.
A little bit.
Yeah.
And it doesn't affect your treatment processes if it's diluted or
Small
has other.
amount, yeah, small amount is okay, but if you have a chlorine, yeah, a lot of flushing and then. Yeah. I think that no matter what happens, you need to continuously,
Clean.
yeah, clean up, so we.
So we've identified cleaning as a critical control point. Yeah. Okay, was that it?
I think it's the last question, yeah.
Yeah, so
Oh,
thank
I
you.
don't have a thank you
Just
slide.
initial
Thank you.
scoping, just to put some boundaries around it, because when you started putting her list of different pathogens that could be in urine, but a lot of them from urinary tract infections, they're not enteric pathogens. They're like, if they ended up on salads and you ate them, they probably wouldn't infect you.
Is it worth though, because you said this is about
Perception.
perception and whether it's the health departments or the public, and you mentioned this morning that to establish PFAS is not in urine, but the public won't know that. I didn't know that. So is it still worth in what you're excluding, communicating that really well, or excluding this because of.
I think it's critical. And even politicians, literally, we had a thing on wastewater reuse. And a politician who didn't come to any of the scientific sessions came in and grandstand and said, well, I've got any influence, I'm not going to let the public in just those endocrine be infected by the endocrine.
I can't get the screen.
And that's a politician.
I'm still logged in.
Yeah. So we can't assume
You
that.
close that one, you will.
Pandemic,
Yeah.
people are
Yeah.
naturally concerned.
So being preemptive with all of those.
Yeah, and being transparent,
Yeah.
we want to be able to.
And in your sorry, that is, you consider how for example, female and male thing.
No, I think
all this one as well.
locked down.
Their perceptions.
Their perception, because I was thinking
No,
male
I'm still-
we're used to using urine and urinals, so. We think.
That's
That's true, but do you have that sort of difference in how female male think?
No, we actually haven't done the perception study
Okay,
for this yet.
yeah.
I think we should try to find a way to do it because it's sort of fallen through the cracks, isn't it, the public perception component.
Well, I wonder how much is Gam going to engage with that?
It's the economics,
But she's still looking at perception.
Yeah, but not so much complex, but.
not explicitly. Maybe in our brains,
Station.
where do we go, we need to somehow work together to cover that a little bit. Some focus groups, you like focus groups? Okay, now thank you very much. And if something pops up in your head, please, just email us, like if you say you read an interesting paper or you found something, don't assume that we've got it. Johanna is working on a systematic review, but you know how long they take. Maybe you could cross mark each other's papers.
You have less, yeah.
Yeah.
I think that's the deal, like, what I want first qual, like, research sometimes, yeah. I don't know.
Yeah, thank you. You can have a copy now.
Right, 20 minutes. We will restart at 4 o'clock sharp so that we can finish on time.
Oh, what time is it? All right.
No, yeah, but it's Okay, no problem.
I'm not sure.
Because first of November, yeah, next month. But we do have one, so it was just-
Yeah, right, which is, but it's interesting, I think that would. By paradigm of the belief systems and all that, like it is a powerful, thing people do, think that most maybe in Australia. Oh, yeah, we'll just put it at the table.
That's right, yeah, it's a word, we're able to talk about.
Good afternoon, everybody.